Hi, today we're looking at Functional Skills Maths Level 2. We've got the Training Qualifications UK exam board. This is examination paper 1 and we're going to start with the non-calculator section. Question 1. Work out, and I'm going to put my commas in here to make it easier to read. Work out 205,983 plus 826,148. So let's write them one on top of the other. So I'm lining up my hundreds of thousands, my tens of thousands, my thousands, my hundreds, my tens, and my units. Okay, so we're going to start off with the units. So 3 plus 8 is 11. Put the unit 1 here and the 110 we carry. 8 plus 4 is 12, plus the 1 we carried is 13. Put the 3, carry the 1. 9 plus 1 is 10, plus another 1 is 11. Carry the 1. Let's bring this comma down. 5 plus 6 is 11, plus another 1 is 12. 0 plus 2 is 2, plus 1 is 3. 2 plus 8 is 10. And put another comma here. So we get our answer as 1,032,131. Question 2. Work out 2.5 times 3.462. Okay, so I'm going to do this as a column, but I'm going to ignore the decimal points in this for now. So I'll line up the 2 and the 6 and the 4 and the 3. Okay, so I'm doing it as if we've got 25 times 3,462. I'll put the decimal point in afterwards. So we're going to start off with 5 times 2, or 2 times 5 is 10. So we'll carry the 1. 5 times 6. Again, or we can think 6 times 5. So we've got 5, 10, 15, 20, 25, 30. Plus the 1 we carried is 31. Now we've got 4 times 5. So it's 5, 10, 15, 20. Plus the 3 makes it 23. And 3 times 5, 5, 10, 15. Plus a 2 is 17. Okay. Now we're going to put a 0 down here because we're moving on to the tens. So 2 times 2 is 4. 2 times 6 is 12. We're coming down. 2 times 4, 4 and 4 is 8. Plus the 1 makes it 9. And 2 times 3 is 6. Now we want to add these two together. So 0 plus 0 is 0. 1 plus 4 is 5. 3 plus 2 is 5. 7 plus 9 is 16. So it's coming 1. 1 plus 6 is 7. Plus another 1 is 8. Right, but we're not going to stop here. Because if you remember, we had decimal places. We had 1 decimal place here. And 1, 2, 3 decimal places here. So in total, we've got 4 decimal places. So if we start at the end, we're going to have to move the decimal place 1, 2, 3, 4 times. So we end up with 8.655. Question 3. Charlie buys a length of wood equal to 3.6 meters. Okay, and we've got Charlie cuts off a length of 1.125 meters. Work out how much Charlie has left. Give your answer in meters. So we're going to start with the 3.6 and we're going to subtract 1.125. Now, so that we've got something to take these away from, we can put a couple of zeros in there. It's not changed the number, but it just makes it easier. Although to start with, we want 0 take away 5. Well, you can't take 5 away from 0 or from nothing. So we move over here, see if we've got anything we can use. We've still got nothing. Here we've got 6, so we can reduce the 6 to 5 and make this 10. And we can do the same again, reduce the 10 by 1 to make it 9 and make this 10. So now we've got 10 minus 5, which is 5, 9 minus 2, which is 7, 5 minus 1 is 4, bring down the decimal point, 3 minus 1 is 2. So we get 2.475. Instead of subtraction, you could count up from 1.125 until you get to 3.6, just a different way of doing it. That should still give you the same answer. Question 4. Work out 7 squared plus 6 times 5. Okay, well, we're always going to do our indices before the addition and the multiplication. So we need to work out this first. Well, 7 squared means 7 times itself. So the 2 means 2 sevens, but multiplied together. So 7 times 7, well, we've got 7, 14, 21, 28, 35, 42, 49. So now we can substitute this into this here. So we have 49, we haven't got the 7 squared anymore, plus 6 times 5. Well, we've got addition and we've got multiplication. Well, with our BIDMAS rules, multiplication comes before addition. So we need to do 6 times 5. We've got 5, 10, 15, 20, 25, 30. So that means we can replace this with 30. So in other words, we end up with 49 plus 30. We can do this as a column. 9 plus 0 is still 9. 4 plus 3 is 7. We get an answer of 79. Question 5. Harper wants to go on holiday. Harper finds 2 offers for the same holiday on different websites. Website A has 38% off. Website B has 3/8 off. Which offer gives the bigger discount? So this can be confusing because we don't know what the actual price is, but that doesn't matter. All we're trying to do is compare 38% with 3/8. So I think the easiest way to do that is probably to try and turn 3/8 into a percentage. And the way we can do that, if we think 3 divided by 8, well, imagine if you were doing it with the bus stop method, you would put the 3 inside the bus stop and the 8 on the outside. Now 8 doesn't go into 3, but if instead we make it 3.000, give it a few zeros, we can always add more if we need them. Now we say 8 doesn't go into 3, so we put a 0 in the decimal point. So we've got 3 carried over. So now we can say, well, how many times does 8 go into 30? Well, that's a bit better because we've got 8, 16, 24, 30, 32 is too many, so 24, that's 3 times. And then from 24, we've got 25, 26, 27, 28, 29, 30. So that's remainder 6. So we carried the 6 over. How many times does 8 go into 60? We've got 8, 16, 24, 32, 40, 48, 56. So that's 7 times with 57, 58, 59, 64 left over. How many times does 8 go into 40? And we're going to keep doing this until we don't have any remainder left over. So we've got 8, 16, 24, 32, 40. That's exactly 5 times. So that's the answer as a decimal. If we want to make it a percentage, we multiply it by 100. So we get 0.375. Multiply by 100, we're going to move the decimal point once, twice. So we're going to have that this is equal to 37.5%. Well, 38 is bigger than 37.5, so we're going to go with website A. Question 6. 60 people attend a dancing school. The classes each person attends are shown below. So in the morning, 28 people do ballet and 12 people do tap. In the afternoon, 15 people do ballet and 5 people do tap dancing. One person is chosen at random. What is the probability that the person chosen attends the morning ballet class? Give your answer as a fraction in its simplest form. Okay, so one person's chosen at random. So we're going to have our answer as a fraction. The bottom number is going to be the total number of people that we've got. In fact, we're told that there's 60, so we can just go straight with 60. But that should be these all added up. We want the probability the person chosen attends the morning ballet class. Or morning and ballet. So this represents the morning ballet people. So we've got 28 out of 60. But it does say give your answer as a fraction in its simplest form. So we've got to think, well, can I reduce 28 over 60 to write it in smaller numbers but still with the same value? Well, they're both even numbers. So the first thing I can do is divide top and bottom by 2. So 28 divided by 2. 2 goes into 2 once. 2 goes into 8. 2, 4, 6, 8. That's 4 times. So we get 14 on the top. And if we do the same with the 60, 2 into 60, well, 2 into 6 goes 2, 4, 6, 3 times. 2 into 0 goes 0 times. So we've got it down to 14 over 30. They're still both even numbers, so we can divide by 2 again. Well, hopefully with the 14, we can just think, well, let's use our 2 times table. We've got 2, 4, 6, 8, 10, 12, 14. So that's 7 times. And how many 2's go into 30? Oh, it's half of 30. Well, we can work this out with the bus stop method, or you might be able to do it in your head. 2 goes into 3 once with 1 left over. 2 goes into 10. 2, 4, 6, 8, 10. That's 5 times. So we end up with 7 over 15, or 7/15. Question 7. Work out the value of A shown in this triangle. Okay, well, what they've helped us here, because both of these are A, so that means that these angles are the same. Okay. So what we can do is we can say, well, we know that the total number of angles in a triangle add up to 180 degrees. So first of all, let's subtract this. We know what that is, so let's take off the 50. 0 minus 0 is 0. 8 minus 5 is 3. 1 minus nothing is 1. So that means that these two angles in total are 130 degrees. That's for 2 of them. We just want 1 of them. So we want to divide this by 2. So 130 divided by 2. 2 doesn't go into 1. 2 into 13. 2, 4, 6, 8, 10, 12. That's 6 times. And 1 more left over for 13. So now 2 into 10 goes 2, 4, 6, 8, 10, 5 times. So A must be 65 degrees. And question 8. Drew wants to put a fence around a garden. And we've got a little diagram here of the garden, the measurements going round. Drew knows the fence panels are sold in feet. How many feet of fence panelling does Drew need in total? Use this conversion graph. Okay, and we've got a conversion graph down here that takes us from, we can go from meters into feet. Because if you look on here, the diagram, everything's in meters at the moment. Well, let's work out what the total distance or the perimeter of this garden is in meters. And then we can convert that into feet and then see how many panels we're going to need. Okay, so if we're starting here, we're going to have 8 plus 3 plus 5 plus another 5 plus 3. Okay, I'm going to make, well, I know 5 plus 5 is 10. So we've got 10 plus 8 is 18. Plus 3, 19, 20, 21. Plus another 3, 22, 23, 24. So we've got a total of 24 meters. Now we need to use our conversion graph. And I'm going to get a ruler to help me with this. So we want 24 meters. So where's that on here? We've got 20, we've got 25. So let's check. 21, 22, 23, 24, 25. So the first thing I'm doing is making sure that these are going up in ones each time, because they don't have to. But in this case they do. So 24 meters is here. So if we use the ruler, we can read across from 24 until it meets our conversion line. And then we'll read down, and that's given me 80 feet. And that goes straight in our answer box there. And that's the end of the non-calculator section. So now we're going to look at the calculator section. Question 1. The diagram shows a square-based pyramid. Draw the plan view of the square-based pyramid on this grid. Okay, well, if it's a square-based pyramid, if it's the plan view, that means looking straight down onto it from above. Oh, I haven't drawn that arrow very well, but looking straight down on top. So what you would see, well, at the base, you'd see this square here. Now, they haven't told us how big this square is, I don't think. I'm going to make it 4 squares. I don't know why, just go with 4. So starting this corner, we'll do 1, 2, 3, 4. Go down 1, 2, 3, 4. Go across 1, 2, 3, 4. Because it's square, each side's got to be the same. 1, 2, 3, 4. Good. Now, what you might see from above would be these lines going down. So if we think this point is going to be right in the centre, so where's the centre of the square? It would be there. So we would see these diagonal lines cutting through the square. Like that. Question 2. Write 3 billion in numbers. Okay, so hopefully you'll know we're going to have a 3 and lots of zeros. Well, 3, 0, 0, 0, that would be 3,000. Another 3 zeros would be 3 million. And another 3, we've got 3 billion. Question 3. Lee wants to buy a new computer for £1,390. If Lee uses a payment plan, the price of the computer increases by 12.5%. How much money will Lee pay in total for the computer using the payment plan? So we're going to want 12.5%. So 12.5. Oh, not 0.15. 12.5 out of 100. That's the 12.5%. We're going to multiply that by 1,390. So 12.5 divided by 100 times 1,390. That means it's an extra £173.75. That's on top of the original price, so we need to add on 1,390. And we get £1,563.75. Question 4. Put these fractions in order, starting with the lowest. So you could spend time working out a common denominator and working out the different fractions, or you can just take your calculator and say, well, 6 over 7 is 6 divided by 7. So this is 0.857. I'm going to go to 3 decimal places, see if that's enough. 6 over 5 is 6 divided by 5, which is 1.2. 8 over 7, 8 divided by 7 is 1.142. Because this is more than 5, we'll round it up to 1.143. And 36 divided by 35 is 1.028. But again, because of the 5, we're going to round it up to 9. So now we're just going to look at which is the smallest. Well, this is the only one that's less than 1. So that's the smallest one. Then 1.2, 1.143, so that's smaller. 1.029, that's even smaller, so that's the second smallest. Then this one, and this is the largest. So, the smallest was 6/7, then 36/35, then it was 8/7, and finally 6 over 5, or 6/5. Question 5. 140 people were asked if they could speak a second language. 126 people said yes. What percentage of the total number of people said yes? So we want 126 out of 140 people. To make it a percentage, we multiply it by 100. So 126 divided by 140 times 100, we get a nice round 90%. Question 6. Harrison needs their new house to be painted within 8 days. 3 painters will take 5 days to paint the house. Unfortunately, 1 painter is unavailable. Will 2 painters be able to paint the house in time? So we can use a bit of logic on this one. Well, if we've got fewer painters, we know it's going to take longer. But let's start off by thinking, well, what if we only had 1 painter to do this? So we've got 3 painters are taking 5 days. So in total, that means we've got 3 lots of 5 days. So that means we've got 15 hours of painting in total. And let's just check. 3 times 5 gives us 15. Okay, so if there was 1 person, they would take 15 hours doing it all themselves. We've got 2 painters. So the 15 hours, we can divide it by 2. So we've still got the 15 from before, divided by 2. It's now 7.5 or 7.5 hours. Well, I'm saying hours, it's days, isn't it? Luckily, it doesn't affect the question here. This is all days. But what we can see is 7.5 is less than 8. So Will they be able to paint the house in time? Yes, they will. Question 7. Oh, let's get it here. There you go. Some friends are planning a hike. The total distance of the hike is 105 kilometres. The hiking route is divided into sections A, B and C in the ratio 3 to 7 to 11. One friend thinks that section B is 40 kilometres longer than section A. Is this correct? Well, let's work out what each of the sections are then, how long they are. And I'm going to do this by drawing a ratio table. So we've got section A, B, C, and we're going to have a total. So if we write the ratio in first of all, we've got 3. So for every 3 kilometres section A is, section B is going to be 7 kilometres. And section C, B would be 7 and C would be 11. So in total, if this is all that we had, we'd have 3 plus 7 plus 11 is 21 kilometres. But they're telling us that the actual hike is 105 kilometres. So how many times bigger is 105 than 21? So what we want is 105 divided by 21. So it's 5 times bigger. So if we multiply all of these by 5, we will get how long those sections are. So 5 times 3. So section A is 15 kilometres long. Section B is 35 kilometres long, and section C, 11 times 5, is 55 kilometres long. One friend thinks section B is 40 kilometres longer than section A. So that would be 35 minus 15. Well, the fact that 35 is less than 40 is already giving us the answer, but 35 minus 15 is 20, which is not equal to 40. So is this correct? No. And we can put that in our answer box as well. Question 8. Jude drives 136 kilometres to visit a friend. The drive takes 2.25 hours. Jude thinks the average speed was less than 60.5 kilometres per hour. Is Jude correct? Show how you decide. So it can help with this to think of a speed, distance, time diagram. Now that's a triangle that looks like this. And if you think the distance you travel, so D, is equal to the speed you're going multiplied by the time you're travelling for. Okay, so D is equal to speed times time. Now in this case, we're trying to work out what the speed is. So if we want the speed, well then the speed is going to be equal to the distance divided by time. So speed equals distance over time. So speed will be, well, the distance is 136 kilometres. And we can divide it by the time, which was 2.25 hours. If we use our calculator, 136 divided by 2.25, it gives us 60.4. I'm going to do it to one decimal place because that's what they've done here. 60.4 kilometres per hour. Well, 60.4, that is less than 60.5 kilometres per hour. So is Jude correct? Yes, they are. Question 9. Sam needs 2.5 pounds of flour to do some baking. The shop sells flour in kilogram bags. Sam buys a 2 kilogram bag of flour. How much flour will Sam have left over? Right, so we need to do some converting here. We've got pounds, we've got kilograms. So what I think we'll do to start off with is we will turn our pounds into kilograms. Well, we know here that 1 pound is 0.454 kilograms. So 2.5 pounds would be 2.5 times 0.454 kilograms, which is 2.5 times 0.454, which is 1.135 kilograms. So we've got 2 kilograms. We're going to use 1.135. We want to know how much is left over, so we're going to do 2 minus 1.135. 2 minus 1.135 gives us 0.865 kilograms. And we can write that in here. No, they haven't given us the units, so we do need to put them in. Now, because we've got a decimal point here, some people might like to turn it into grams instead and say 454 grams. And you'd end up with an answer of 865 grams. That's absolutely fine, so long as you put 865 grams and not 865 kilograms. So either answer will do, 865 grams or 0.865 kilograms. Question 10. Kai gets paid a net amount of £1,418.50 each month. 29% is deducted from Kai's gross pay before they're paid the net amount. Okay, so the net, that means after they paid their tax. Kai wants to check the gross amount before the 29% was deducted. Kai rounds the net amount to the nearest £10 and uses the rounded value to check the gross amount. What answer should Kai get? Right, so they round the net amount to the nearest £10. £1,418.50. Well, that's going to be somewhere between £1,410 and £1,420. And we can see it's going to be closer to this one. Okay. Or you can think nearest £10, so this is the tens. Look at the one after it, which is an 8. So if it's 5 or more, we round up. So we'd end up with 1,420. Okay, so we've done the first bit. We've done our rounding, £1,420. Now, we want to get back to the original amount. Now, 29% has already been taken off. So we need to add on 29%, but we need to add on 29% of the original amount, not 29% of this amount, because this amount actually represents, well, it's going to be the original 100 minus 29. So if you do 100 and take off the 29, that means that that actually represents 71% of the original. So we want to get back to what 100% of it was. So what we can do to start with and say 1,420, well, if we divide it by 71, that'll tell us what 1% was. Then if we multiply it by 100, it will take us back to the original amount. So 1,420 divided by 71. Okay, so 1% would be £20. Then multiply that by 100, we get that the original amount must have been £2,000. Question 11. Madison uses this water bottle whilst at the gym. The bottle is in the shape of a cylinder with internal dimensions. Radius equals 4 centimetres, so from the centre to the edge, and height is 22 centimetres up here. Madison's personal trainer recommends a new water bottle that holds 8% more water. What size water bottle should Madison buy? So we need to work out what the volume is of this water bottle and then increase it by 8%. So this is drawing the water bottle flat, but if you think it's a cylinder, so actually it would be something like a circle like this. So this is our circle on top with our radius of 4 centimetres. So if we want to work out the volume of our cylinder, well, we're going to need to work out the area of the circle. So let's say the volume, we can't see that up there, the volume is going to be the area of the circle, and then we're going to need to multiply it by the height, okay, which they've given us as well. So let's start off by working out the area of the circle. And hopefully you remember that the area of a circle is pi r squared. And with algebra, where we've got letters next to other letters or next to numbers, it means multiply. So pi, we got 3.14 times r squared. Well, r squared means r times r. And in this case, r is 4. So it's going to be times 4 and times 4 again. So 3.14 times 4 times 4. So 50.24, and its area, so it's going to be centimetres squared. So we said we then need to multiply it by the height, which in this case is 22 centimetres. So if we multiply this by 22, we get 1,105.28, and because it's volume, it's now centimetres cubed. Right, so we need to increase this by 8%, because I want a bottle that holds 8% more water. Now what I could do is I could work out 8% of this and then add it on. What I'm going to do is I'm going to say, well, if I want 8% and then add it onto the original, that's the same as 108% of the original. And if I do 108 divided by 100, I get 1.08. So in other words, I just need to multiply this by 1.08. Okay, so I'm keeping the 100% part, and then I'm increasing it by 8% here. If you're not comfortable doing this, work out 8% of it and add it on, and you will get the same answer that I'm about to get here. So 1105.28, we get 1,193.7024 centimetres cubed. And if we want to, we could round it. So for our answer box down at the bottom, let's round it to 1 decimal place. So we'd have 1,193.7. That's less than 5, so we just leave it like that. Question 12. 2 years ago, Nikki paid £8,000 into a new savings account. The savings account paid 4% compound interest per year. Nikki sees this car for sale. Car for sale, £12,975. All the money in the savings account will be used as a deposit towards the car. The balance will be paid in 20 equal monthly instalments. How much will each monthly instalment be? Okay, so we've got to work out how much this £8,000 is now worth. take it off of the cost of the car, and then divide that by 20 to get the monthly payments. So, 2 years ago. So what we've got, right, we've got £8,000. We need to increase that by 4% for 2 years. So after 1 year, it's going to increase by 4%. So multiply by 1.04. So where this is 104 divided by 100. So going up by 4%. And then for the second year, we're going to do the same again. Increase it by 4% the second time. So we get 8,000 times 1.04. So after 1 year, it would be worth 8,320. And after a second year, it would be worth £8,652.80. It's money, so we need to make it 80 rather than just 0.8. So the next thing we need to do is say, well, if that's the deposit, how much is left to pay afterwards? So we want 12,975 minus the £8,652.80. Well, I can put that in my memory and then say 12,975 minus memory recall. We're left with £4,322.20. We want 20 equal instalments, so we're going to divide that by 20. And we get £216.11. And we can write that in our answer box. Okay, question 13. Riley grows apples and oranges. The weights of the apples collected on Monday are shown below. The weights of the oranges collected on Monday are summarised below. So for the oranges, the mean weight is 188 grams and the range is 112 grams. Riley claims, Riley claims on average the weight of the apples is greater than the weight of the oranges. And also the weights of the apples are more consistent. Are each of Riley's claims correct? So what we need to do is that we need to work out the mean and the range for the apples. Okay. Well, the mean is calculated as the total divided by the frequency. So the total is going to be adding all of these values up. 173 plus 151 plus 182 plus 248 plus 214, which gives us 968. And frequency, so how many have we got? 1, 2, 3, 4, 5. So divide it by 5 and we get a mean of 193. They've done it in whole grams, so I'm going to round it up to a whole number, so 194 grams. Okay, now we want the range. Well, the range is the biggest minus the smallest. So what's the biggest value? That's the biggest one, 248 grams, and the smallest, 151. So our range is 248 minus 151, which gives us, we can put it here, 97 grams. We can put it here as well. Right, so now we've got values for apples that we can compare to the values for the oranges. So on average, the weight of the apples is greater than the weight of the oranges. Apples is greater than the weight of the oranges. That looks true. So we can say for claim A, we can say yes, 194 is greater than 188. Now for the second claim, the weights of the apples are more consistent. More consistent means they're closer together. So in other words, it means that they've got a smaller range. Well, the range of the apples is smaller than the range of the oranges. So again, we can say yes. And that's because 97 is less than 112. If you want to write it out with more words, you can, but this is absolutely fine. Okay. Question 14. Taylor is going to Finland for 6 months and wants to know the average monthly temperature. Taylor finds this information. Okay, so we've got the average temperature in Fahrenheit for November, December, January, February, March and April. Taylor uses this formula to convert the median temperature from degrees Fahrenheit to degrees Celsius. Okay, so we've got this formula here, which is C equals 5, and then in brackets, F minus 32, all divided by 9. Where C is the temperature in Celsius, here, F is the temperature in Fahrenheit. Here. Taylor thinks the median monthly temperature is colder than -1 degrees. Is Taylor correct? Okay, so we're going to have to work it out. The starting point to go in here, we need F, our temperature in Fahrenheit. But Taylor uses the formula to convert the median temperature. So we need to work out the median value. And the median is the middle value. Now, to do that, we have to start with this, have them ordered from smallest to largest. So what's the smallest one? 28 is the smallest, then 29, then 30, then 32, then 35, then 46. So if we write them out in order, we would have 28, 29, 30, 32, 35, and 46. And then we cross out the smallest and the largest. Keep going in pairs. We're left with 2. So if we're left with 2, what we need to do is add them together and divide by 2. In other words, find the midpoint. So we need 30 plus 32 equals, make sure you do equals, especially if you've got a scientific calculator, then divide it by 2, and we get 31 degrees, and that's degrees Fahrenheit. Now, you might not have had to work this out. You might be able to just see, well, what's going to be halfway between 30 and 32? Well, it's going to be 31. Now we can put this in the formula. So we're going to have 5. Now, when you've got a number next to brackets or a letter or something, it means multiply. But we've still got the brackets here. So instead of F, we've got 31 minus 32. We'll close the brackets. Divide it by 9. So don't be tempted to do this all in one go. I would do it step by step. So we're going to keep the 5 times, and we're going to work out this bit in the brackets. So we've got 31 minus 32. So our answer is actually -1. I'm going to keep it in brackets. And then that's all going to be divided by 9. So we've got -1. We want to multiply that by 5 to give us -5. Then divide it by 9. We get an answer of -0.555. That's going to go on forever. Now we just need to compare that to -1. Well, -0.555 is not as cold. It's a smaller, if we ignore the minus bits, it's a smaller number, which means it's closer to 0. It's not as cold as -1. So it's actually bigger than -1. So is Taylor correct? No, they're not. Okay, so we can put no here. So if it was colder, it would need to be minus and then a bigger number than 1. So it'd be like minus 1.5, minus 2, minus 7. So more cold. Okay. And finally, on this paper, we've got question 15. Okay. Alex has a table in the shape of a rectangle with a semicircle on each end. Okay, we've got a diagram there for us. Alex wants to cover the surface of the table in fabric and finds these prices online. So we've got fabric, price per square metre. We've got various different values. Alex uses the modal price to estimate how much it will cost to cover the surface in fabric. How much does Alex estimate the fabric will cost? And if we move this up, give your answer to the nearest whole pound. Use pi equals 3.14. So the pi bit should give you a clue. We're doing something with circles here. Right, so the modal price, so it's the same as the mode, or it's the average, but we're looking at the value that occurs most often. Okay, so we can look at each one and we can say 3.75. How many times have we got 3.75? We've got 1, 2, so this occurs twice. £2.99, that only occurs once. We've already used the 3.75, so we can ignore that. £4, that only occurs once. £5.25, only once. £4.99, only once. And £5.75, only once. So in other words, the only value that we've got more than once is this £3.75. So that is our modal price. Okay, so that's our starting point. Now, what we do need to do is work out the actual area of the table. And then we're going to multiply it by our modal price. So I'm going to split this up. So I'm going to say, well, we've got a couple of things going on here. First of all, we've got a rectangle. Let's draw my rectangle here. Quick sketch. We've got 4 meters by 1.5 meters. So the area is going to be the length times the width. That's the area of a rectangle. So we want 4 times 1.5, which gives us 6 meters squared. Now we've got these two semicircles. Well, I'm going to do them over this side. If we've got a semicircle and another badly drawn semicircle, we've got one circle. Now we know the diameter is 1.5 meters. We want the radius, so just the distance from the center to the outside. Well, the radius is going to be the diameter divided by 2, or half of the diameter. So 1.5 divided by 2 gives us 0.75. And the reason we're doing that is because we want the area of this shape, and the area of a circle is pi r squared. So we're already told that pi is 3.14, and r, the radius, is 0.75. Squared means multiplied by itself, so multiply it by another 0.75. 3.14 times 0.75 times 0.75, and we get 1.76625 meters squared. Okay, so we have a total area of 6 meters for the rectangle, or 6 meters squared, plus 1.76625 meters squared for the two semicircles, which gives us 7.76625 meters squared. So we've got the area, we've got the price per meter squared, so we can work out how much it's going to cost. So it's going to be £3.75 for each metre squared. So that's times 7.76625. Now, because this is fabric, I'm assuming that we can buy 0.76625 of a metre. Nothing said that it has to be exactly a round number of metres, which sometimes we get with these types of questions. But because it hasn't said it, I'm going to leave it unrounded. So I've got my 7.76625, multiply that by 3.75, and we get 29 point. So it's money. We want it to, well, actually we want it 2 decimal places, but they said to the nearest whole pounds. Well, 29.1, we're going to round that to just 29 pounds. So we can leave it there. And for completeness, let's put it down here. So that's the end of the paper. I hope you found it helpful. Please like the video, subscribe to the channel, turn your notifications on so you find out when I upload more videos, and I look forward to seeing you again soon. Thank you.